A star is essentially a huge fusion reactor. Each nuclear reaction produces a force which blows the star outwards. Another force, gravity, combats this, working to compact the star inwards towards the centre. It is this resulting equilibrium between nuclear fusion and gravity that defines the star, but this battle between the star forces has an inevitable conclusion. For eventually, the star will exhaust the fuel supplies. Without the fuel to sustain its fusion reactions, the star cannot maintain sufficient internal pressure to resist its own gravity, and it rapidly collapses. At this point, if the star is massive enough, this collapse releases huge amounts of energy, causing the star to explode as a supernova. Afterwards, the gravitational field continues to act upon the remnants of the star. If this remnant is large and exceeds of 3 solar masses, it will now be compressed by gravity to such an extent that it becomes smaller than the Schwarzschild radius and sinks into the fabric of space and time. A black hole is born. Black holes can spin over 950 times a second. Objects at its horizon travel at half the speed of light. Black holes are incredibly dense. One the mass of the Earth would be only 9 millimeters across. To escape the pull of a black hole's gravity, you must travel faster than the speed of light. Their gravity is so intense that it can slow down time. This is called gravitational dilation. Black holes can collide with each other, forming even larger black holes. When a black hole's core continues to collapse, it is reaching Planck length. That is the smallest measurable unit in the universe. They are invisible to us. Gravitational waves from merging black holes can cause wandering rouge black holes. A black hole 30 million times the Sun has been found. It swallowed another black hole 1 million times the Sun's mass. They break down mass into energy 50 times more efficiently than nuclear fusion. The nearest black hole to Earth is 1600 light years away. Black holes are not always black. They emit electromagnetic radiation. Here is the layout of a black hole. The event horizon of a black hole is a boundary in space and time where only light and matter can enter the black hole. Light and matter falling inwards pass the event horizon and can only move towards the centre of the black hole. Nothing escapes the event horizon once it is within. The ergosphere is a region in which an effect known as frame dragging occurs, making it impossible for someone to stand still within. In this process, space and time is dragged in the direction of the rotating black hole at speeds greater than the speed of light in the observable universe. The static limit disk forms around the black hole, consisting of matter that forms an omnidirectional cloud around it. Matter in the disk gradually falls into the black hole, and the static limit disk is visible as long as the black hole has a continual source of matter. The singularity is the centre of the black hole, where space and time becomes infinitely curved. The singularity is infinitely dense, and the laws of physics break down here as matter reaches its presence. However, the singularity has no volume. For non-rotating black holes, the singularity takes the shape of a single point, whereas for rotating black holes, it forms a ring singularity.